Hi, welcome back. In this last video, we're going to do one more example because we haven't done 180 degrees yet. As a review, remember our rotations are going to be counterclockwise around the origin, the point 0, 0. It is an isometry because our shape is not changing size. Then we looked at the three rules that we use for rotating around the origin for 90 degrees, for 180 degrees, and for 270 degrees. Remember, each time you see a negative symbol, it doesn't mean that the number there is negative and that the number here is positive. It means whatever number you have here, either positive or negative, if you have a negative sign here, you're going to use the opposite of that number. If you don't, you're going to keep that number whatever it is. Whether it's positive or negative over here, it'll stay the same when you move over here. Okay? Then we did an example with 90-degree rotation. We did an example with a 270-degree rotation. And so now we're going to do 180-degree rotation because we haven't done that yet. Right now I can see this is in quadrant 2. 1, 2, 3, 4. We always start in positive, positive and go around. This is in my negative, positive quadrant. So if I go 180 degrees, if I rotate 90 and then I rotate 190, I should expect to find my figure here. Okay, so let's see what that looks like when I graph it. Okay, or when I apply the rule. My rule for 180 degree rotation is the opposite of x, the opposite of y. So I'm going to write down my rule, the opposite of x, the opposite of y. Okay, so when I see a negative 2 and then I have a negative x, I don't just leave it as a negative 2. Remember, this means the opposite of x. So if I have a negative 2 here, I'm going to do the opposite of that, which is going to be a positive 2. Then the opposite of y. Now 0 doesn't have an opposite, so it stays just 0. Okay? Now the next one. The opposite of x, the opposite of y. So the opposite of x, the opposite of negative 3 is positive 3. The opposite of y, the opposite of 2 is negative 2. Okay? The opposite of x is 2. The opposite of y is negative 4. The opposite of negative 1 is positive 1, and the opposite of 2 is negative 2. Okay? All right, so let's graph these points. A prime is at 2, 0, 1, 2, 0, A prime. Okay? B prime is at 3, negative 2, 1, 2, 3, negative 2, B prime. C prime is at 2, negative 4, C prime. And D prime is at 1, negative 2, D prime. Now when I sketch this in, it kind of looks like a translation. It kind of looks like I just took this figure and I just slid it from here down to here, right? It looks like I just took every point and I went to the right and then I went down. But the reason I can tell this is not just a simple slide translation is because look at my points. I have A at the bottom, now A is at the top. C is at the top, now C is at the bottom. B is on the left, D is on the right, and then look here, D and B have switched places. When I look over here, A is at the bottom, and then I go clockwise to name it around the figure. Watch what happens when I go 180 degrees. A is at the bottom, and then it's labeled clockwise around the figure. A, B, C, D. Okay? So it has truly been rotated 180 degrees. Remember yesterday, or in the last lesson, we talked about rotational symmetry, or reflectional symmetry. Today we're going to talk about rotational symmetry. When a figure is rotated around its center less than 300 degrees and maps itself. So basically, how many times can you return this figure and land on itself all the way back to the beginning? So for example, this point right here, if I rotate a third of the way around, my picture is going to look exactly the same. And then if I rotate it again to here, it's going to look exactly the same. And if I rotate it to here, it's going to look exactly the same. So it has 3 lines of rotational symmetry. Okay? When I look at the next one can kind of be tricky because a lot of times you go, oh, an infinite because it's a circle. But this one has design in it, right? So because it has the design in it, that's going to affect the rotational symmetry. This point right here at the top of my V part of the symbol is not going to be, it's not ever going to line up on anything except when I get here, but then the W will be misplaced, right? It'll be upside down. So this one, you have to go all the way around your 360 degrees. You have to do one full rotation before you get back to looking like the VW symbol, right? So this only has one line of rotational symmetry. You have to go all the way around to get there. Okay? This one, how many times can I rotate it? Because it's just this simple regular star inside, I can rotate it 1, 2, 3, 4, 5 times to map it back onto itself. So this one has 5 lines of rotational symmetry. Okay, so this one has 3, this one has 1, and this one has 5. Okay, thank you so much for watching. If you have any questions about rotating 90 degrees, 180 degrees, or 270 degrees, go ahead and make sure you attend your sync time and ask your teacher for help with manipulating these rules and using your opposites and your switches. All right, thank you so much for watching.